Welcome to GER Hub Mathematics and Statistics lessons. Thank you very much for your subscriptions to our channel so far. Thank you for telling someone about us. Please continue to do so. Tell someone about GER Hub and the contents on mathematics topics, statistics topics, and even research project writing topics we have and stand to offer them. Thank you for your likes to our videos, your shares of our videos, and watching our videos extensively. We are very grateful. That being said, what will be the focus of this video? It will be to solve problems on logarithm. We shall be looking at our solver series on theory of logarithm part 2, and we shall start with problem number 1. Simplify each of the following. So how do we simplify problems in logarithm? So I'm going to start with 1a. We have log to base 2 of 8, the root of 8, and log to base 3 of the root of 3. So what do we do in this case? We are going to apply the laws we know of logarithm, that log a to base b plus log a to base c, or to base b, log b to base b will be equal to log a b in base b, the product of a and b in base b. Now, that will not immediately apply to this, so what we have to do is to look at the problem carefully. We are given log to base 2 of the root of 8, and we are given log to base 3 of the root of 3. So, what is the square root of 8? What we are going to do is, we are going to start with saying, writing log 8, we are going to write log 8 as 8 raised to power half. So that becomes log 8 raised to power half to base 2, plus we are going to write log square root of 3 as 3 raised to power half to base 3. Now, if you apply this law of logarithm that says, so all this becomes equal to this, So if you apply this logarithm, this law of logarithm, a raised to power 1 over n, or a raised to power n to base b equals n log a raised to base b, then you are going to have this for this particular problem. This will become half log 8 to base 2, because the power clearly comes as a coefficient here to multiply the logarithm of a in base b, and this becomes half log 3 to base 3. Now, the problem continues here. We can continue this problem over here, and it becomes half log 8 can be written as 2 raised to power 3, so I'm going to write it as 2 raised to power 3 to base 2 here, plus half log 3. Now, take note, this can now come to multiply 3 multiplies half to give us 3 over 2. So this becomes log 2 to base 2 plus half log 3. Now, take note, in logarithm, the log of a to base a is 1. The log of a thing to that thing is 1. So this means that this will become 1 and this will become 1. So this we have 3 over 2 times 1 plus 1 over 2 times 1. And that gives us 3 over 2 plus 1 over 2. And 3 over 2 plus 1 over 2, LCM is clearly 2. So this is 1.5 plus half, and that gives us 2. Okay? So take the LCM. The LCM is 2. 3 plus 1 is what you end up having as the numerator, and you simplify it, it will give you 2. Now, let's look at what we did here. What we did was to take the LCM. 2 in 2 is 1. 1 times 3 gives you 3. 2 in 2 is 1. 1 times 1 gives you 1. That will give you 4. 3 plus 1, 4 over 2. And 4 over 2 divided by 2 gives you 2. Now, that is just for those who may not have understood what happened there. Now, for B, problem B, 1b, you have log to base 3 of root 81. What would that be? So, we shall start with saying log to base 3 of 81 raised to power half. Okay? Now, you may have even started with saying taking the square root of 81 at once, and that will give you 9. Okay? So What is the square root of 81? It is 9, because 9 times 9 gives you 81. So this will be log to base 3. Instead of writing 9, I can write it as 3 raised to power 2 because the base is in 3. Okay? And that will give us, by that law I quoted earlier, this will become log 3. So what law have we used here? We have used this law, log a to power n in base b is equal to b log a to power n log a to power b to base b rather. So that is the law we are using here. When the logarithm of a number has a power, when the number whose logarithm you want has a power, then in that base, the result will be using that power to multiply the logarithm of the number in that base, okay? And that is the law we use here. So here, we shall use another law of logarithm, that log of a number to that number as its base is 1. So this ends up giving us 2 times 1, which is 2. And that solves problem 1b. Now, if you go over to problem 1c, in problem 1c, we are given log square root of 125 to base 5. Okay? So we are asked to simplify. So I'm going to bring c here, log square root of 125 to base 5. And that is equal to log to base 5 of 125 raised to power half. Okay? And by that law I quoted just not too long ago from now, we have half log 125 base 5. So whenever you have the logarithm of a number, whenever you have a number whose logarithm is sought and that number has a power, the power will multiply the logarithm of that number in the given base. So that is the reason why half becomes the coefficient here times log 125 in base 5. Now, that being said, we are going to simplify further. We can write 125 as 5 raised to power 3. And again, by that law, the 3 multiplies this half, and that becomes log 5 times half times 3. And that becomes 3 over 2 log 5. Okay? But because log 5 is equal to 1, you end up having 3 over 2 times 1, which is log 5, and that will give us 3 over 2. Now, that solves problem C. For problem D, for problem 1D, we have half log 8 to base 4 plus log 32 to base 4 minus log 2 to base 4 equals, half can be written here, and I'm going to do this. I can actually take my half back. A simpler way to solving the problem, I can reverse the procedure by bringing this as 8 raised to power half. Just by reversing this law we applied again, log a n to base b is equal to n log a to base b. Using this law, we can reverse from this, to this, okay? And that's what I did here to this term. Now, plus log 32 to base 4 minus log 2 to base 4. Now here, to this 2, I'm going to apply the law of addition. Log a to base b plus log b to base b will be equal to log ab to base b. So I'm going to apply it to these 2, and that will give us log to base 4 of 8 raised to power half times 32 minus log 2 to base 4. So that's what we have. Now, that can, of course, become log 8 raised to power half is 2 raised to power 3 times half. That gives us 2 raised to power 3 over 2 times 32 can be written as 2 raised to power 5. Okay, so minus log 2 to base 4. Now I can further simplify that as 2 raised to power 3 over 2. By indices, that becomes 2 raised to power 3 over 2 plus 5 minus log 2 to base 4. Now at this point, I could decide to either simplify. I could simplify further to get the LCM of 2 and 1 is 2. So I can have 2 raised to power 2 here, and that will give us 2 in 2 is 1. 1 times 3 is 3. 1 in 2 is 2. 2 times 5 is 10. 10 plus 3 gives us 13. 13 over 2 minus log 2 to base 4. Now at this point, I can now apply this law of subtraction. This. And this law requires that A over B is what you have in base B. So using that law, using this law here, this will become log of 2 raised to power 13 over 2 divided by 2, all in base 4. Now that can be written, of course, by indices as 2 raised to power 13 over 2 minus that is minus, or okay, I can write it, let me write it for those who do not understand, as this divided by this. Okay, now you can proceed as writing it as this 2 raised to power 13 over 2 minus 1, because 2 is the same thing as 2 raised to power 1. Okay, and when you simplify that, that becomes log to base 4 of 2 raised to power, LCM is 2 again. Now I'm doing this, I'm making sure that I leave nothing undone, because I want you to really understand what is going on. So 2 into 2 is 1. 1 times 13 is 13. Minus 1 into 2 is 2. 2 times 1 is 2. So that gives us log to base 4 of 2 raised to power 13 minus 2 is 11. 11 over 2. Okay, so the problem becomes 11 over 2 log 2 to base 4. Now there is a law, reciprocal law, but before I apply that law, I'm going to do this. 11 over 2 log 2 raised to power 2. So whenever the law, according to that law of reciprocal, of base, reciprocal power, now you have, if the base carries a power, then it comes as, this comes as, the power becomes a reciprocal multiplying the coefficient already, and that becomes log 2, 2. So log 2, 2 is 1. So you end up having 11 over 4 as your final result. Now what law did we use here? The law we used here was the reciprocal power, that log A b raised to power n is equal to 1 over n log A to base b. Okay, that was the power, that was the law we used, and this gives us this result. Okay, and that solves problem 1D. Now take note, this problem could have been solved at once. Problem 1D, there is another way you could have solved problem 1D. Let's look at it again. So half log A to base 4 plus log 32 to base 4 minus log 2 to base 4. Now, a student could decide to apply all the laws at once, but before doing that, it is best you take this. I could have done this. Since this is a reciprocal, I can do this. I can take this half over here, and this is 432 minus log 4 2. At this point, a student could decide to just take it all at once and say 8 raised to power half times 32 all over 2. Okay, where the addition law applies to the first two and the subtraction law applies to the last one, and that will give us log to base 4 of 2 can cancel this to give you 16. So this is 8 raised to power half times 16, and that will give you log 4 2 raised to power 3 over 2 times 2 raised to power 4, and that would have given you log. Okay, this is what I'm doing, just in case you did not follow me. I'm saying that there's another approach one could have used to solving problem number 1D, and that would mean taking this over here and it becomes this by that law of logarithm we used earlier on, and then doing it at once, applying the addition law to the first two and the subtraction law to the last one. So the subtraction law would make the last one divide, and that will give us 2 would cancel 32 to give us 16, and this will reduce to 8 raised to power half. Take note, 8 is 2 raised to power 3, so 2 raised to power 3 times half will be 2 raised to power 3 over 2, and 16 is 2 raised to power 4. So that gives us to base 4 this. Okay, so that was what we did. We are looking for another way to solve problem D, 1D. Now, if you apply that law of indices, this will be 3 over 2 plus 4. And that will give us log to base 4 of 2 raised to power. LCM is 2. In this case, this is 4 over 1. LCM is 2. So you end up having 2 in 2 is 1. 1 times 3 is 3. Plus 1 in 1 in 2 is 2. 2 times 4 is 8. And that gives you log 4 to base 2 to base 4 raised to power 11 over 2. And that will simplify to, this is what you have. And when you apply that law of logarithm again, it becomes this, 11 over 2 log 2 to base 4. Now, if you apply that reciprocal law again, this will be 11 over 2 log 2 raised to power 2, and that will give you 11 over 2 times 1 over 2 according to that reciprocal law. So this will be log 2, which is 1, and that will be 11 over 2 times 1 over 2 times 1, and that gives you 11 over 4 again as your result. So that's another way to have gone about that problem. Now let us go to problem number 2. Let's go to problem number 2. In problem number 2, we are given problem number 2a. We are asked to, problem number 2a requires that we solve this. Okay, so let's start with simplify each of the following. Log x raised to power 9x. Now we are going to just apply that law of power of the number, law of powers, and that will be log xx. Log xx is 1, so this will be log times 9 times 1, and that will give us 9, and that solves the problem. So the problem is that easy. Log x raised to power 9 in base x means 9 can become a coefficient by multiplying log xx, and log xx is 1 because the log of anything to that thing is 1. 1 times 9 will give you 9, and that solves that problem. So let's go over to 2b. If you were asked to solve 2b, 2b requires that we simplify log 13.5 to base 3 minus log 10.5 to base 3. Now you can just apply the subtraction law. This law, the log of a to base b minus the log of b to base b equals log of a over b to base b. So if you apply that law, you are going to have log to base 3 of 13.5 all over 10.5. Okay, now that is what you are going to get by that law. Now you can actually divide this. You can write this as 13.5 can be written as 135 over 10, and 10.5 can be written as, now this can be written divided by, you can write this as 135 over 10 divided by 105 divided by 10. Okay, because 10.5 is 105 divided by 10. So this will give you log to base 3 of 135 over 10 times 10 when it becomes multiplication all over 105, and that becomes log to base 3 of 10 cancels 10. 5 can divide this. When 5 goes into 135, when 5 goes into 105, it gives you this gives you 1, this gives you 1, this gives you 21. When 5 goes into 13, that will give you 2. It goes in 2 remainder 3, it gives you 7 here. Okay, so if you keep up with the simplification process, 3 will divide here to give you 7, 3 will divide here to give you 9. Okay, because 3 times 9 is 27 and 3 times 7 is 21, so you end up having 9 over 7. Okay, so that becomes log to base 9 over 7, 9 to base 3. Okay, let me cancel this. Now I would want to get it done this way. I could actually apply the law of change of base, or just leave my answer like this. Okay, so if you want to simplify further, you could have log 9 to base 3 minus log minus log 7 to base 3. You could have that, and this will give you log 3 squared minus log 7 to base 3, and that will give you 2 log 3. That will give you log 2 log 3 minus log 7 to base 3. Okay, that will give you that, and it simplifies to this. If you continue the problem over here, it simplifies to getting 2, because log 3 is 1 minus log 7 to base 3. So the problem becomes 2 minus log 7 to base 3 as your result. Okay, now let's see. That's for problem B. Now let's see if we could have done that alternatively. Let's see. Now what if we had tried to get it done at once with starting like this for 2b? What if we had done this? Log 3.5 to base 10 minus log 10.5 to base 3. If we had done this, you will notice we would still have had 135 over 10 to base 10 minus log 105 over 3. 105. Okay, this was base 3. Sorry, this was base 3. This was base 3, and this would have given us 10 here. Okay, so this was base 3. Sorry. Now this will give us, at the end of the day, we'll end up having log 5 can divide. That will give us to base 3. You end up having 5 into 135. That will be 2 into 13, 2. Remainder 3, and that would have been 7 over 2. Okay, minus 10. 5 into here is 2. That would have given you again. It would have given you 21 all over 2 in base 3. Now, if you had simplified that further, you would have obtained this: log to base 3 of 27 over 3 times, or divided by 21 over 2, according to that subtraction law. And that will give you, this would have been 2. That would have given you log to base 3 of 27 over 2 times 2 over 21, giving you the same result we obtained earlier on, and this will be 27 all over 21. Now, of course, you know that 27 and 21 have some factors in common. So what are those? What can you divide through by? You have 3 can divide 27 to give you 9. 3 can divide 21 to give you 7. So your result is this, which can also be written as log 9 to base 3 minus log 7 to base 3, which reduces again to 3 squared 3 minus log 7 to base 3. And that would have given you 2 log 3 minus log 7 to base 3, which is 2 minus log 7 to base 3 again, because 3 is 1. Log 3 is 1. Now, if you go over to problem 2c, let's go over to problem 2c, where we are asked to simplify this. So, if we were asked to simplify this, what would we do? This would have been log 12.5 to base 5 times 2, according to the addition law, and that will give us log 5. 2 times 12.5 will give you 25. So the problem reduces to 5 squared to base 5, and that will be 2 log 5, and that will give us 2 times 1, because log 5 is 1, and the result is 2. Okay, and that solves problem C. So it is that simple to go over these problems. What about the last case? What about the last problem? Let's see for the last problem. So what if we were given the last case, that is 2D, problem 2D. Now in problem number 2D, we are given this. Okay, so log 27 to base 3 plus 2 log 9 to base 3 minus log 54 to base 3. Now, all you have to do is simplify by taking log 27 to base 3, leave it that way, go over to the next thing, take this over here, and it becomes log 9 squared to base 3 minus log 54 to base 3. We have applied that power law here by taking this coefficient back to 9 to become a power. Now, you can now simplify this by taking 27 times 9 squared, all in bracket, to base 3 by the addition law, minus log 54 to base 3, if you want to do it in bits. And that will give us log to base 3 of 27 times 9 squared all over 54. And of course, 27 into itself is 1, 27 into 54 is 2. And that will give us log to base 3 of 9 squared over 2. Now take note, log to base 3 of 9 squared. 9 squared is 81, so I could easily write here as this as 81. And that will give us log 81, which is to base 3 minus log 2 to base 3. Now that will give us log 81 is 3 raised to power 4 to base 3 minus log 2 to base 3. And that will give us 4 log 33. That will give us 4 log 33 minus log 2 to base 3. Now, 33 is, log 33 is 1, so this gives us 4 times 1, which is 4, minus log 2 to base 3. Now, all you have to do in solving problems in logarithm is to remember the laws of logarithm. So please go over our videos on the laws of logarithm. Watch them extensively. Watch them extensively. Please like our video, subscribe to our channel for more videos on different contents on mathematics, statistics, and even research. And I will see you in a bit. Thank you very much. Thank you very much. And thank you very much.